Okay, this video will be about integration by parts. Integration by parts is a technique used basically when none of the other techniques that you've learned in the past will work out. Here's an example. The integral of x times the sine of x. Okay, so if you were to see this integral and start to approach it, you might think it was some sort of u substitution. It might be some sort of trig integral, but none of that's going to work out because these two parts being together really interrupt any of the techniques you might try to use. If you say, well, what if I let u be sine x? Well, that's a good thought. If u is sine x, then the integral of u du would require the derivative of sine x. So that's not going to happen because there's no cosine x, and there's no way to get a cosine x. So u can't be sine x. U can't be x. You could do an integral of sine, the integral of sine, but you have this extra x floating around, so that's not going to happen either. Try all day, and there's not going to be a good way to solve this one other than integration by parts. So the first question we're answering, why do I need to know integration by parts? Because sometimes you'll get an integral that none of the other techniques will work for. So let's just back up for a minute and just talk about the basis of this formula that I'm getting ready to show you. Okay, you remember, we'll have a little break for knowledge here, not just go right into an example. The derivative with respect to x of uv. This is one of your good old friends, the product rule. The product rule says you do 1 times the derivative of the other plus the other times the derivative of the one. Equals u dv dx plus v du dx. So we've got, I always do first times the derivative of the second plus second times the derivative of the first. It doesn't matter what order that goes in, but that's the way I do it. If you were to go and integrate both sides of this equation, the integral of the derivative on the left is just going to be uv. Just kind of cancel each other out. And on this side, we have the integral of u, and I'm going to integrate, by the way, with respect to x. I should be technical and throw that in when I put my integration symbol in. But I'm left on the right side with the integral of u, and then the dv dx times dx kind of just cancel out and leaves me with the integral of u dv. Okay, then I'm going to integrate the next one and get the integral of v times du. Now, if I just kind of manipulate this formula a little bit, I'm going to get the integration by parts formula. This is something that you need to memorize by heart starting today. The integral of u dv equals uv minus the integral of v du. All I did was move this to the right and move this to the left. So when it's all said and done, what I come up with is a formula where inside my integral I have two parts. One of them is going to be a function u. The other one is going to be a dv that happens to be the integral of some other function v. So we're going to figure out what v is and go on from there. Okay, so first thing first, make sure that you have down and start to remember this formula. You might have talked about this formula last year, but we're going over it just to make sure. All right, so let's get back to our example, the integral of x sine x. All right, so when we approach an integral like this, we've got a decision to make. Which one is going to be u and which one is going to be dv? Now, sometimes, by the way, in our formula, we know what u and dv are when we know the problem. We're going to have to come up with v here, which means we're going to have to integrate dv. And we're also going to have to come up with du, which means we're going to have to differentiate u. So whichever ones you pick to go here for u in dv, make sure that u is something you can differentiate, take the derivative of, and dv is something you can integrate fairly easily. And also, if it can become simpler, that's good. Okay, so x is either going to be u or dv. If I make x dv, then I have to integrate dv to get v. Right, whichever one I choose to be u, I'm going to differentiate. Sine doesn't really matter. It just bounces back and forth between sine and cosine, plus and minus. So that's not getting any more or less complicated. But x would be really nice here because the derivative is 1, and 1 is always simple. If I make dv sine x, then when I integrate that, I get, remember, I always remember the derivative of sine is cosine, so the integral of sine is negative cosine. All right, those pluses and minuses are easy to forget, especially after a long summer. So, this is a good choice, it seems. It might turn out that this didn't work, but I think it's probably a pretty good choice. Once you have gotten your 4 parts, now you just remember your formula and plug in. I'm going to write it again. So, uv would be x times negative cosine x. I'm just going to put the negative out front. Negative x cosine x minus the integral of v du. V times du is 1 times negative cosine x. All right? So notice, whenever you go through the first step, you're still left with an integral. But hopefully that integral is one that you can solve in a much more easy fashion than the original. We've basically simplified it. We've taken the extra x out, and we're left with just the integral of cosine, which we can deal with. Okay? So let's finish it up. The negative x cosine x is fine. It's already in good shape. It's just this negative here and negative here. Let's just get rid of those, make them, cancel them out, make them positive. Then we're left with just the integral of cosine. The integral of cosine is positive or negative sign. Remember, positive. And because we are proper calc students, we're going to put a little plus c on the end. And there we go. So overall, the integral of x sine x is negative x cosine x plus sine x plus c. All right, so there's a good example of an integration by parts. All right, let's turn the page. Try another example. What if we start with the integral of x squared cosine x? We need to choose a u and a dv in such a way that when we integrate and differentiate, they get simpler. I'm going to let u be x squared for the same reason. If dv were x squared, then v would be x cubed over 3. I'm just getting more complicated, so that's not going to happen. So let's let u be x squared, which means that du is 2x, and v is the integral of cosine, which is sine. Now we go to our formula and just plug in. And the more you use this formula, the more second nature it will be, and these will get easier and easier as we go. Okay? So, my formula suggests you get in the habit of writing this formula. Okay? My answer then will be u times v, which is x squared sine x minus the integral of 2x 2x sine x. So now we're in pretty good shape. However, there's one little problem. The integral that resulted, the second part of our integration by parts formula, over here, the integral that results is 2x sine x. So, like I said before, this is a case where we're trying to get this to be simpler. All right, we need to have an integral that we can do, but we ended up with something with an x and a sine x in it. And hopefully you remember from 5 minutes ago, you can't just integrate something with an x and a sine x in it. That requires integration by parts. So it's possible that you have to do integration by parts twice, and that's what's happening here. So I will help you get it set up and let you just finish it up on your own. All right, in this case, we're going to do our sub-integration by parts. Let u be 2x. If you wanted to move the 2 out, you could. It'd be fine either way. Let du be 2. dv is sine x. d is the integral of sine, which is negative cosine. And now we do an integral here that is very similar to the one we did on the last page. Don't forget, when this happens, that your overall answer is still going to involve this first part. So we're going to get x squared sine x minus, also don't forget that this negative sign applies to everything that happens next. So use brackets, use space, be organized. This area is where we do the next uv minus the integral of v du. So something, we're going to have uv minus the integral of v du. And that's going to go in there. And like I said, I'll let you finish that up to keep this video a little short. So the overall answer is going to have 3 parts, and we can talk about the final answer in class. So I will see you then. I'm out.